Welcome to lesson 14 on page 129. We're going to talk about the normal distribution. And we start here on page 129 with a graph, and you will see how it's somewhat symmetrical. So when we are dealing with the normal distribution, that implies symmetry. So we are dealing with this normal curve. So when you see like this lovely curve, we call that the normal curve. And with that, we will have the mean is always right in the middle, and you will see they tell us what the mean is. And then standard distribution kind of tells us, standard deviation tells us kind of the spread of our data. So when you look at the questions here, go ahead and hit pause, answer the questions, and come back. So the questions, the height of the bars, you will notice the height of the bars talk about the frequency. So, how many babies have that particular birth weight? And number two, what do the width of the bars represent? Well, let me get rid of some of these colors. You will see the width of the bars are that span of data. So we've got like, from 2 to maybe 2.05 or something like that. So the width is of the bars is a span of birth weights. And number three, I've already mentioned that this is symmetrical. And when we talk about the distribution of birth weights, the distribution implies to the how spread out are they, right? So you can see you have some over here, you've got some over here. The distribution is the spread of the birth weights. All right, let's go on over to page 130. And you will see this lovely bar graph here. So now what I want you to do is hit pause, and I want you to answer questions 5 through 10 here on page 130 dealing with this graph. And you will get your information straight from this graph. So go ahead and do that. All right, looking at number 5, the class intervals. So the class intervals is the width of the bar. So when you look at each one of these bars, you will notice that they have a width of 5. So if I go back to this picture, right, here's 160, here's 170, and there's one bar in between. So if you would cut that in half, this would be 165. So the interval, or the width, would be 5, right? They each have a width of 5. Number 6, what do the heights of the bars represent? Well, the heights would be the frequency. So how many women fall within that particular height? And then when it says most of the women in Anthropology 105 were of what height? Well, biggest bar is between 160 and 165. Looking at this next set of questions here, if a woman from Anthropology 105 were selected at random, how short it was possible of shortness? Well, when you look back at the graph, oh, wrong button. The shortest they could be is right here, and we know that with the width class intervals of 5, that would be a 145. So that allows that to be 145. The average height, they tell you right here that the mean is 163.4, and then the bar at the far right, which is right here, represents 180 to 185, and if you notice, there's only one person in that data spot. So hopefully you did okay on those questions dealing with that graph. And now we are going to move on to page 131. All right, so at the top, we've got 3 graphs that are pretty much normally distributed, and you can see that I would say the graph on the far right, this commute times 1, is probably the most normally distributed. It's really it fits pretty nicely under that curve, but you'll notice what I want to point out is, do you see how, like, I want to call this one is fat, right? You can see the fatness. Ooh, that was a bad color. The fatness of this graph. Whereas you look at the first one, look how tall and skinny it is. So when we compare a tall, skinny, as in the birth weights, and then more of a short and spread out fat one, that's going to be the big difference between these curves. So the spread, or the fatness of the graph, that is impacted by the standard deviation. So for all of these graphs, when we talked about the mean will fall directly in the, those are not in the middle, but the mean is directly in the middle for all of them. The standard deviation is implied by the spread. So the fatter it is, or the wider the spread, you're going to have a larger standard deviation. Whereas if you have a skinnier one, like here in our birth weights, we'll have a smaller standard deviation. So it might be important for you to read these paragraphs here on this page, or in this section. This is one of my favorites. I love mean standard deviation. But let's look on page 131 at numbers 13 and 14. Okay, I want you to hit pause and answer these questions. Okay, so hopefully you went back to page 129 and then here in page 130 for number 14, and you found the mean and the standard deviation. Just for reference, X bar is known as the sample mean, and S is known as the sample standard deviation. Those are shortcuts that we use in the statistics class, and I'm lazy, so I will use them. But you can write out mean if you want it. It doesn't really matter. Now, when we are working on these normal distributions and creating things, as we will here very shortly, we need the mean and the standard deviation to make these appropriate graphs. So you'll want to make sure, sometimes it will be given to you, sometimes you're going to have to actually calculate it. Don't worry about the standard deviation. That we're not going to get too much into that, but you know how to find the average, right? You add everything up and you divide by how many you have. And using Excel, love Excel, we can highlight some data and find standard deviation that way if we need to. So let's go ahead and move to the bottom of page 131, where you will see these graphs. Okay, so notice we've got a solid line that represents spring and a dotted line that represents fall. So you'll notice that the solid line is taller and skinnier. If it's tall and skinny, that means it will have a lower standard deviation. So when you look at question number 15, which curve appears to have a lower standard deviation? Well, it's the one that's least spread out. It's going to be the tall, skinny one. So spring will have a smaller standard deviation than fall, because we can tell that just by the looks of the graph. Now in question number 16 here, more F's. Well, an F is below 60. So if I cut my thing off at 60 and I look to the left, notice how that's higher. So the fall had more F's. Okay. And then, let me erase my orange graph here. So question 17 here, more C's. Well, a C is from 70 to 80. So that one's a little bit harder to see. But I would say that it was probably spring, because look at how high those are, right? It's way, way higher. Whereas if you look down here, let me change colors just a little bit, it's a much closer window. So I really think spring has more C's. So you can kind of use, well, and because the data is all squished together in the middle, which makes more sense as well that it will have more C's. All right, so that's kind of more of a visual representation of standard deviation and the mean. All right, the empirical rule. This is going to be crucial to your life. You will definitely need, and you'll be given the graph of this for the test, but you have to know what it is and how to use it. So when I'm looking at this, I see that 68% are within one standard deviation, 95% are with two, and 99.7% are within three. And I'm actually going to create a little video that is just on the empirical rule, if I haven't already, and get that in there, because sometimes it's good to see. And that video will show how this graph is concocted. So if you're confused on where these numbers came from, I want you to watch that other video that is titled The Empirical Rule. And it'll just be short and kind of explain exactly how we get these numbers. So going into this data, okay, so these questions here, the area under the curve. Now, I showed you earlier X bar and S. So X bar and S are the sample mean and sample standard deviation, and they show you here mu and sigma, which represent the population mean and the population standard deviation. So, again, don't get too caught up on these symbols, but it's good at least that you've heard them. So when I'm looking at question number 1, mu plus sigma and mu minus sigma, this is one standard deviation away both directions. So if you think back to where we just were, one standard deviation is 68%. So 68% is one standard deviation each way. Now when I look at number 2, this implies two standard deviations, right? Because it's 2 sigma. And if sigma represents standard deviation, we're going 2 in both directions. So that would give me 95%. And then question number 3, this 3 sigma would be 3 standard deviations and that would be 99.7%. So the empirical rule gives us an opportunity to kind of estimate where our data lies, and we can use that excitement-wise. Okay, area under the curve to the left. Now, I'm going to just draw a basic curve down here so I can reference it, right? So we've got our empirical rule. And as I stated earlier, the mean always cuts in half. So, that's great. I'm going to actually go back to the other one because this will be a little bit easier. So in question number 4, it says mu minus sigma. So the area under the curve to the left of mu minus sigma, that's right here. So if I'm going to the left, I would add up these 3 pieces. So 13.5 plus 2.35 plus 0.15, that would give me 16%. So going back to number 4, we'd have 16%. Now number 5, hope you're not getting seasick from my going back and forth here. Number 5 talks about to the right of mu plus 2 sigma. Well, mu plus 2 sigma is right here. So to the right of that would be these 2 values, add them together, and I would get 2.5%. And number 6, if all the percentages of the diagram would add up together, right, it's all the data, so you would have 100%. And then number 7 is kind of, I like number 7 because number 7 goes with number 5. In number 5, we found that red circle area to the right. Well, in number 7, it says, well, what about the area to the left? Well, if I know that the area to the right is 2.5%, then the rest of it would be 100 minus 2.5%, right, which would be 97.5. So we can use that concept as well when dealing with these problems. And don't fret, we're gonna be dealing with all of these in terms of concrete numbers here in our next few examples. All right, now let's get to the actual using of these things. So, page 133. All right, we're going to do this first one together, and then I'm going to cut you loose on the next few. But to create these, we've got this basic chart, and we know that the mean always is in the middle. So, oh wait, we've got to work on these problems first. Psych. All right. You know what? I'm going to create a new video at this point. Stop. This is, yeah, I'm going to end here. I'm going to pick up a new video on page 133 with better pictures.